Afternoon, everyone. I'm Matthew Marge. I'm excited and honored to be here along with all of you, and looking forward to share a bit of what I've been doing since I left CMU and a little bit of my reflections today. So first, a little bit about myself. So right now, I'm a researcher at the Army Research Laboratory, which is the Army's corporate research lab. And I've been there for over 7 years now, where I've been chiefly responsible for introducing dialogue system technology into the Army, along with many great collaborators. And I'm also an adjunct professor at Georgetown University, where I teach a course on dialogue systems as well. And I earned my PhD from the Language Technologies Institute. And beyond my interest in conversational AI and dialogue, I also am interested in integrative AI systems, which is really the process of combining and coordinating multiple AI competencies that perform perception, reasoning, and action, and also speech and natural language processing. So it's really, to me, the multimodal interactive aspect as well. And so when I began my time at CMU, I arrived with a genuine curiosity about how to bridge the gap between speech and robotics. And what I wanted to do is, see what can we do if we can talk to robots? What are the potential capabilities we can enable? And that led me to the naturally more difficult challenge of how does dialogue work with robots in the first place? That's really, really hard, I ended up finding out. But with the guidance of Alex, I joined the Team Talk project, which was investigating multi-party spoken dialogue between humans and teams of humans and robots. And in my thesis work, I actually was exploring ways that robots could ask for help and clarification when they face usually ambiguous instructions and impossible instructions. And using evidence from the speech signal among other areas of context that a robot would perceive in its environment. So if in this example here, a little tiny text, but you say to the robot, let's say in this team, one is called Alfie, right? And you say, go to the table. Well, what if there's multiple tables in the environment? Well, the robot can learn over time different ways to describe the world, and maybe learn even user preferences of what ways to describe the world. And in the case here, the robot decides to ask, do you mean the table on my left or my right? Could be using other properties of the world, but in my thesis work, I implemented an instance-based machine learning algorithm that would basically learn user preferences by modeling context that the robot perceives at a given moment and ask for clarification. And fortunately, I've been able to continue that line of work in dialogue with robots in my current position at the Army Research Lab. And so for my first few years there, I led a project where we collected a corpus called Scout, which is one of the largest and most comprehensive data sets of robot-directed spoken dialogue that's been collected in collaboration with USC. And that's been great, and also led to enough data to create a system that we call the Joint Understanding and Dialogue Interface, or JUDI for short. And it's a conversational interface to autonomous systems that is able to do things like interpret spoken language and ground it to a robot's physical context. So obviously when a robot's in the world, is perceiving its environment, with LiDAR, laser scans, camera. And so this system is able to take the spoken language and ground it to the context and know that, when I say the table in front of you, it's, full stack, it's going to autonomously determine that and refer to that. And also just a little bit more about my time at ARL, I was fortunate to be one of 10 DoD researchers to be selected for a fellowship from the Office of the Secretary of Defense, where I explored ways that physical agents like robots could learn new concepts in real time using dialogue. So imagine you want to teach a robot something new that it's part of your group or your team, and you have to basically use spoken language in real time. And finally, one of my career highlights to date was being able to co-organize an NSF Future Directions workshop on speech and robotics, where we laid out a roadmap, and actually several folks in the room came to that workshop, a roadmap for the challenges really for bridging speech and robotics for the next decade. A lot of exciting work that can be done there. And because videos are fun, I want to show you a demo of the JUDI system. And so what you're going to see in this on the left side is a robot we call Husky. And this is its laser map it's building as it moves around the world. And the task is to move a few different objects in the environment. And here you see the robot in simulation as it moves around its terrain. There's a few different objects in the terrain, like you have some barrels that it already perceived and added to its knowledge, or what's called a world model. And it has to do tasks like move to barrels or cones and so forth. So you'll hear about 3 examples. The first one will require the human to kind of clarify because it was underspecified. A second example will be one where spatial language is used to disambiguate a referent, in this case, a barrel. And a third one is actually a multi-step instruction where you give a series, a sequence of actions in one instruction, and the robot breaks it down and does that. So you'll hear the operator, which is me, do the instruction giving.
Husky.
You also hear another
Husky
voice.
reporting.
That's Kevin's voice.
Go to.
Where'd Kevin go? He's gone.
Where should I go to?
The nearest barrel.
Roger that. I will go to the nearest barrel.
Robot's movement is 2 times the speed, just to speed it up a little bit. So, but the interactions are real time.
Take a drive over to the barrel on the left.
Roger that. I will take a drive over to the barrel on the left.
Now drive to the cone and the rock closest to it.
Roger that. I will drive to the cone and the rock closest to it.
So,
wait for the Mars rover.
Yeah, no, we had that. We actually look at a spacecraft environment for the similar task domain. Yeah. Yeah. So the motion plan is still a work in progress, but we have a better one now. I promise you. It still uses a mission planner to decompose the instruction to do the multiple checkpoints, and also even that second instruction with take a drive. Naturally, that won't actually break down to an action of doing the drive behaviors. So we are leveraging advanced form of semantics called abstract meaning representation. You might have heard of it if you're an NLP researcher, AMR, to infer that that's the drive behavior. Yeah, so to wrap up, thanks, Alex. I want to share a little bit of my reflections from CMU. Many great memories, but a few stand out. So within my first month of being here, Randy Pausch gave his last lecture, and I was there in person to witness it. And it was very inspiring to me. One of my favorite quotes of his was, "The brick walls are there for a reason. They're not there to keep us out, but to show how badly we want something." And to me, that was very inspiring. And also during my time, about 2 years after, they built the new Gates-Hillman complex, which for me was really improved my ability to interact with the School of Computer Science more broadly because everyone was closer together. That was really good. And the Dialogue on Dialogue reading group, which is what Dan talked about. I first joined it and later led, which was the weekly reading group on Dialogue, where Alex sponsored the bagels. And thank you for that. And the same for the Sphinx lunch. So I also look back to the Sphinx lunch. It was a weekly, lunch. I don't know if anyone else talked about it today, but it's gone back to the 80s, right? Dates back to the 80s. This is really wonderful experience. And one thing I want to remember is that when I reflect on is that one Sphinx lunch is when Thomas Schaaf gave a demo of the Amazon Echo, like in person, and that was like 2014 or so, or maybe 2012. And to know the rest is history for that, right? It's really interesting. Sphinx lunch. And then, for me, the takeaway from being part of the speech group has been the importance of interdisciplinary collaboration, and also just the value of building community around your research. I think that's been also really great for me. And I always could rely on the speech community for feedback and guidance in my work. Thanks. Yeah, thanks, Alex.